Hey. Hello everyone. Thank you for joining. Can you hear me alright? Or is this too loud? Oh, I'm hearing myself. That's bad. That's better. Know if you want it louder or not. This is probably the way I'm going to speak. Also, are you hearing like there's a fan going on here and some air conditioning and also the world outside because it's I'm keeping the windows open in order not to die. This is a bit of an improvised stream because I just want to get into streaming again, and I've been feeling a bit unproductive lately, and I just figured that just doing streams might be what I need. So I figured that instead of like trying to schedule them properly, I just and prepare them properly, I figured that I would just let's just start streaming and see what happens. And the people that join will join. Chocobo Can Fly asks, does anybody say that you look like Tony Stark? Yeah, I've been told that I look like Robert Downey Jr. Not sure if that's too accurate actually. Robert Downey Jr. Find some images of him. Alright, it's like is that a likeness? I don't know. Maybe a little bit. Maybe a little bit. It's a nice compliment though. Always nice to hear that, oh, you look like this fancy celebrity. Hello Vikas 5914. Welcome to the stream. Nice to see you here. So again, this is just an improvised stream. Thinking about, like, I'm trying to get into machine learning and I've been procrastinating on it for such a long time. So I figured what better way to get going is just title the stream, let's code a neural network in JavaScript and just get going, you know. How are you this fine? Well, for me, it's afternoon, 2 o'clock. How are you people? What are you doing? Are you at work? Is it evening for you? What do you do when you turn into a stream? I'm trying to drink more water. And I use this habit app on the iPhone that called Streaks to just check every time. And it just, after a while, it just turned really boring to keep checking like this little list. It just felt inhuman. Feels like I was just doing actions that my iPhone wanted me to take, which just sucked. Instead I just started, you know, the habit is now fill this, come on, focus, fill this bottle with water at the beginning of the day. Just keep it there. And then the habit is whenever this glass runs out, I fill it. And when I see it, I just take a sip whenever I feel like it. What kind of hair product do you use? Hang on. Like, my hair is fucking out of control right now. Like, I really need to get a haircut. This is what I do when, like, things start to get really bad. Is pull it up like this, which makes it just make it seem like, oh, it's this wild guy instead of this guy who just can't go to the book a fucking hairdresser's appointment. But I used just some styling paste. It's this is just some random one actually. I just enjoy like these pasties. I won't put it out of the tube. It's like these soft wax pasty things. Oh. You're playing what? Are you, are you playing badminton, tennis or something? And you stop your badminton to watch your stream. That's nice. Right, 44 people joining. It's really cool that I can just start streaming without even pre-announcing and people just drop in. That's insanely cool. So happy that you're here. Making sure that I'm getting things done. So, I'm just gonna talk about what we're doing today. Let me pull up Notion. I'm trying out this new note-taking wiki thing called Notion. Unfortunately, we can't increase the font size here. It's a bit of a bummer, but yeah. How's the sound levels, by the way? Are they okay? Or is the noise outside bothering you? I think there is a hypothetically there is a noise cancelling plugin that I can add. I think I'm already using it actually. Its noise cancelling level is at -30 decibels. Sound is good, says Danny. Thank you. Bogdan Theodoro need to learn to read Twitch names properly. Says that you can hear the cars outside. Yeah, like they are really loud. I have my office in a or my studio is in a co-working space near, like in this industrial area, which is really like I really like it because it's a space where like everything is just so messy and dirty. I'm kind of like I don't know, that just stimulates me. I used to work at Spotify and it was this like it was a really nice workplace. I don't want to complain, but it just after a while it just turned out to be just too tidy, I guess. A kind of in order to be creative and feel good about yourself, you just need a certain level of mess. I like that this place constantly changes and it's just sort of weird and imperfect. Anyway, whenever I start a project, I kind of often want to start with what and why. Do you hear the seagulls? You probably do. They're really... Can I do... Oh, I can do headers there. What and why. Like it's a JavaScript, a video series. Create a video series where we learn to code a neural network from scratch. So we're not going to use any libraries or anything like that. Not like, so we're not going to use TensorFlow JS or anything of those high-level libraries. We're just going to like try to do this as plain as possible in order to try to understand what a neural network is and how it kind of works inside of JavaScript. I'm not even sure if this is the best approach to learn machine learning, to be honest. But a neural network seems like something that is used a lot and like a good place to start if you just want to start in the middle, because I've tried to get into machine learning from the perspective of doing these like learning about linear regression and learning statistics, and it's just so boring, you know. It becomes so abstract and becomes like learning statistics and stuff, and it kind of feels like if you're doing neural network, maybe we get into at a good point, maybe, or maybe not. Maybe this will become just another of this series that I start and never end, or never continue. Captain Craft says, "Hey, it's the fun function guy," and hey, it's Captain Craft guy. And also, yes, I am sponsored by Kellogg's. It's this is just some random t-shirt that I bought in Tokyo. People often ask me where I get my t-shirts, and I get them at all different weird places. Camera is shaking but while typing. Yeah, funny. Yeah, sorry about that. Eventually I'm going to fix my camera rig so that I can use the same camera for streaming as I can do as I use for shooting the YouTube shows, but yeah, we're not there yet. Like, I need to do a little bit more streaming before I can justify that, because there's like switching cameras and lenses and stuff. That is such a huge investment. Hemardisons asked, will you use TensorFlow? No, we will not. The purpose of the series is kind of to learn, like try to get into machine learning. Like I'm gonna, in order to get started with machine learning, create a video series where we'll learn to code a neural network from scratch, and this is the crucial part, like not from scratch. We will also not assume and we're also gonna not knowing much math, statistics, or other machine learning concepts. And this is very convenient because, you know, I, as a person, do not know much math. I don't know much statistics, and I don't know much about machine learning in general. I have a huge advantage teaching programming, actually, over other people, because I don't know much computer science. I don't know much math. I actually didn't study natural sciences. I studied theater, which is why, you know, like I'm kind of in my shows. Hi Expressy, welcome to the stream. So nice to have you here. Captain Craft asks if YouTube is your full-time job these days, and yes, it is. It is since hang on, I think since November was when I made the jump. It's been it's been good. It's been good. Yeah. So hang on. And when it comes to these things, I tend to, you know, just create a work log. And let's say, can I get today's date? Insert the date reminder instead of text. Type to mention a date. What is this? Today. Interesting. Trying to learn Notion. I think that this is kind of just to add. This is not really to write date. All right, hang on. Today is May 13th. And today is 14:41. And we are starting streaming the first episode or something. So I'm not sure how we're gonna do this. Like, this is enormously an experiment, because normally when I make the YouTube shows, I tend to I tend to just, you know, sit in my own chamber and just fiddle around with things and not like not get much feedback at all. And I think of it like this I'm going to do a little bit differently. So this, what you're watching now, is actually not going to be the episodes themselves. This is going to be like me preparing for the episode or doing it, and then I'm going to create a kind of supercut of it for the YouTube channel, and I'm going to add commentary to it. I'm not sure if that's going to work, but that's the experiment at least. We'll see how it pans out. Maybe it will be shite, and then I won't do it again. Vika says apply for Twitch partner. Well, I will eventually. You have to stream to a certain degree in order to do that first, and you have to stream like a lot, like like several times a week for a month, and for like several hours. So in order to do that, I will probably, like, I will not be doing that on a regular basis. Fuck you, Twitch. Not a chance in hell. But I might be able to, like, just do like a very intense time where I just get up until to those levels and then apply. There, Tyrion, do you use a matrix lib then for all the matrix fun? No, we won't do that, because if we use a library, we won't understand what the hell is happening. I want to a large degree, try to do like all the necessary math stuff from scratch. Otherwise, it will be just like feed this thing into this thing, and then magic happens, and we won't understand anything. That won't work too well. We're trying to hit understanding here, and trying to, you know, hang on, let me switch back to coding here so that we like get my notes. Expressi asks, do you recommend any coding site to do JavaScript problems on? The JavaScript videos are awesome, by the way. Thank you, Expressi. I don't know. For beginners, I tend to just recommend Code Academy. That seems nice, but generally, like, I'm not a kind of, you know, problems kind of guy. When I learn things, I tend to pick like a project that I want to bring into existence, and then I just slam myself against it. Slam my head against it. Try to figure out like how to do things. That's the way I tend to operate. Lorenzo, hello from Spain. Big fan of yours. Yeah. Like, we should use that as a term for people that like the channel. Fans. Chance Labs, any recommendations for warming up and getting into the right frame of mind when starting your workday? That's a good question. I don't actually have a good answer. What do you think? Like, does the chat have any ideas? One trick that I have a really big problem with that, actually. I tend to, like, one trick I have that actually works is to, whenever you end the day, to document the next action, where to begin the next day, so that you can instantly, you have a note that gives you a hint of where the hell you left off. That has been very, very useful to me. And hypothetically, a lot of people like to, you know, clean their desks to make sure that you're ready for the next day. I've tried to get into that a lot of times, but I fucking hate cleaning, so I don't do it. Sleepy Coder says, I love you, MPJ. I love you too, Sleepy Coder. Vika says, listen to voodoo people. That's actually a good idea. That is very nice. At some point I want to like get music into this streaming thing. A lot of streamers use music. It would be really nice to just listen to like some really good electronic music and just get into things while coding. You can listen to the same. What is the song you use for the intro? Which song is that? Can't tell you off the top of my head, and it's weird to look it up right now. It's one of the electro swing songs on Epidemic Sound. I use Epidemic Sound for almost all videos. Himardzen says, morning cold shower and tea. Cold showers is the best. I actually do it in the evening, right before. Right now I'm trying to build this offlining routine. I figure that I just have this cutoff point where I just put the phone into offline mode, and then I go take a cold shower. And then after that, once you're like in this mode where you just go cold, you go jump into the bed and just between the covers, and you like cuddle up with a Kindle and reading. Reading fiction. Right now I'm reading the Dresden Files. It's a really good, level of excitement for me. It's just very, very nice, and gets me like neutralizes the day and gets me out of it. So I read for like half an hour until I just feel like ready to go to sleep, and then I just put the Kindle away and put the lights out. Digital Dummy says, are your previous streams available somewhere? Yeah, it's a patron reward. So if you are like a patron on the $5 tier or something like that, it's you can download them. I'm still experimenting with this thing. I think that at some point I should just start with Twitch subscriptions for the, and then I don't know. I don't know exactly how to coordinate this. We're all like it's all an experiment, but the streams are available for patrons at the moment. Lorenzo says, you can also make it interactive. Let's say that you have a bot that makes JS questions, and people will eventually make points along the way depending on how fast they answer the questions. Think about it this way, your audience will be more participatory and find your fun and catchy to be part of the stream. I definitely want to make this more interactive. I really like the interactivity of the Twitch stream. I just find it just so pleasant to just sit around and talk to people and get interrupted constantly with questions. I really like that. So it's very possible, like whenever I made these streams, they tend to not be very productive because I just tends to do segues into questions, and we're kind of fine with that, to be honest. Wolf, good morning from Oklahoma. Hello, Oklahoma. Twitch subscriptions aren't worth it. Twitch steals a lot and mutes videos and recordings when there's a copyrighted music playing. Well, they have to mute copyrighted music. That's not up to Twitch. That's up to copyright law. And I don't know. I find, what is it that Twitch takes? 30%. I find that completely fair. I don't mind that at all. Dear Tyrion, I will look forward to this series. I just finished my neural evolution project for uni, which I will hand in tomorrow. Oh, that's really good. Hopefully you can be helpful for this. Twitch takes 50% before taxes for affiliates. Depends on the contract with partners. That doesn't seem right though. Twitch subscriptions share. Oh, it is actually it's actually 50-50. Julian. Oh, that's quite a lot. Whoops. Yeah, we'll see, Yeah, as 327 Wolf says, the coding train has been doing a lot of ML. Nice series. That is actually the series that I'm going to base this on. He's pretty amazing. Let's actually have a look at that. See if we can. Where is that thing? So this is the one that I've been watching. I watched this yesterday, and the thing that I'm going to try to do today is to like figure out how to do the examples that he did in JavaScript. So create a perceptron that does things. This is like, just to set expectations here, this is absolutely not going to be like the neat packaging that Fun4Function projects are. This is going to be me just, you know, playing around, trying to learn this, and to give you a bit of a glimpse into my process of while I make a Fun4Function episode. So it's going to be around me like watching a video a lot, videos a lot, reading articles, thinking. I'm not even sure if this is going to be pleasant to watch at all. Maybe it will, maybe it not. Maybe it will be some like a very interesting like discussion with people. Shit, I keep forgetting to switch to the same view as I have. So yeah, I don't know if we I haven't set up a sound capture properly, so you probably won't be able to hear what I hear. Can I even hear this?
I'm going to build
Help.
a set. I'm going to build.
Oh wait, I need to. Jesus, a lot of things happening. I'm going to connect my headphones so that I can actually read what the hell is going on. But it's really like this is very this actually thankfully suitable. Cool. It's really good that he has subtitles. We can hear it. Oh, you're actually hearing this? That's interesting. Are you hearing what he is saying right now? Right now, are you hearing what Schiffman is saying? I don't think you should be able to. Yeah, because like I had it out for like you were hearing it through my speakers. Perhaps we should actually do that. Let's do that. It won't be perfect, but it will work. So let's watch some Schiffman then.
Video. Hello, welcome to a video that at this present time doesn't exist. But when you are watching this video, right there to the right of 9 genetic algorithms will be the number 10, and it will say next to that neural networks. So I am embarking on a journey to learn about neural networks, what they are, how you program them, what's kind of like math and stuff you need to know to make them work, and then what kinds of creative and experimental outcomes can you have? Now, it should be said that there are lots and lots of machine learning libraries out there. There are lots of examples and resources for doing this. I want to hold on. I'm still talking. I don't know where did I put that book? It's over here.
Oh, guys, that's for
I want
Christ's
to
sake,
reference this book, Your Own Neural Network, by Tariq Rashid, which I used to develop a lot of the materials that I will be presenting to you and developing during this series of videos. And I should also say that, you know, and this book, has all sorts as how to program your own neural network from scratch and without even knowing anything about programming in Python. Because, as I might have said earlier today, any reasonable person would start and make a video tutorial series about programming a neural network.
Hang on. I want to make a note. I'm gonna make a sort of, can you get a list here? List, to-do list by that book. What's the book called? What's the book called? Links, books is like here, this one. Let's actually use this affiliate link. This one. There we go. Let's make sure that I remember to buy it. Buy machine learning book recommended by Schiffman. There we go.
From scratch in Python, but I'm not very reasonable or logical, and I do just constantly make mistakes with everything, and here's a mistake that I'm going to make. I'm going to do all this in JavaScript, and the reason for doing that is to have everything run in the browser on the web, and also really for me to learn about how to do this stuff. So I am going to build a simple neural network library in JavaScript, not to make something efficient, not to make something robust, but to learn about the mechanics of how all this stuff works. Because ultimately, and you might want to just enjoy your summer, or maybe you're watching this during the winter, and get outside and do something else and not watch these videos and just skip ahead to like later, because I'm going to do a bunch of coding challenges and projects that involve that neural network library and also other neural network libraries, namely something called TensorFlow, in future videos. But these first videos of building the neural network library, which I will do over a series, are really just for me to learn how to do this stuff. And if you want to watch and sort of give me some good feedback and see if you can follow along and improve on what I'm doing and help me with it, that would be great. So, okay, hello. Am I just rambling here? I am. But why are we here? So I'm going to go...
Want to increase the speed
so the Nature of Code materials, and this video sits in the Nature of Code playlist, is all about looking at things in nature, in our physical world, and trying to unpack those things and understand the algorithms behind those things, and see if we can convert those things, those algorithms, into code. Oh, this is like going, it's like auto-playing. How do I stop that? And turning those things into software to make animations and creative projects. Why not look at something really interesting in nature, the brain? So this is kind of a loose diagram of this idea of an actual biological neural network. Apparently I have one here, I'm struggling quite a bit these days, where there are these entities called neurons, and they're connected to other neurons, and there's a lot of mystery to this and a lot of recent research to neuroscience. What I am focused on in this series of videos is what kinds of computational systems can be built inspired by the actual biological neural network.
I really find that these things, the neuron, dendrites, axon, and brain things, I'm not sure if I find them super helpful when it comes to like thinking about these things when explaining them. I just find them super distracting. I try to learn what an axon is and a neuron, and like starting to explain the brain science stuff can just be a huge distraction when learning machine learning, I think. I wish that people would just like this is a perceptron. It's called that because it's inspired by the brain, but let's not get into that at all, and just let's go into it. He doesn't get too much into it, thankfully, but I don't know, I just find it's very easy to get distracted by a lot of things when it comes to machine learning, I think. And we're gonna try to not do that and not get into statistics and stuff too much.
Neural network, biological brain, and made into something called an artificial neural network. And what kinds of applications and outcomes can we create? So what is the analog? What is the neuron in our code? How does it receive inputs? How does it generate outputs? So my brain does this. It receives all these inputs, you know, from light in the room that travel through my retina and into the brain, and the signals that produce outputs and allow me to catch something or read some words. How can that process be simulated in software, and what types of outcomes can we generate? And the very first thing that I'm going to do is look at the simplest possible neural network. It's not even a network at all. It has one neuron, a processor neuron, that receives two inputs and generates an output. And that's called a perceptron. So if you look at the next videos in this playlist, I'm going to build in processing a perceptron example just to show the mechanics of how this works and to produce a sort of trivial example that doesn't necessarily have a very powerful outcome, but gives us, because if we can build...
So this is, he talks about a perceptron here. He's going to, like, I watched this, sort of skimmed this video a little bit before starting this, and he builds basically just a simple, a class that is just a thing that takes a bunch of inputs and then produces a bunch of outputs. I'm wondering if we can model this as, you know, a function. He calls this a processor here, but it's really a perceptron. I'm not sure exactly how we're gonna do it, but it's very simple.
Build and understand how this single neuron receives inputs, processes those, and generates an output, then we can start to connect those together to create more sophisticated systems that can begin to generate outputs based on more complex outputs based on more complex inputs. And this is kind of it sits right there in the world of machine learning. This idea of, I have some data that I want to make sense of. That data is an input to a machine learning algorithm. That algorithm is going to generate an output. So maybe the data is an image. The machine learning algorithm is going to guess, is it a cat or a dog? Or maybe that input is the specs of a house, you know, square footage, number of bedrooms, et cetera, and this machine learning system is going to generate an output, a predicted price. So there are lots of other machine learning algorithms besides just neural network-based ones, and I do have another video series that covers some of those, but ultimately I want to learn how a neural network works so I can place it right there and start to make sense of data, generate outputs from it. So if you want to continue along, the way this video series will work, first there'll be a perceptron, which is this thing. Then I'm going to talk, after the perceptron's done, I'm going to talk about what the limitations of the perceptrons are and why it is that if we can create a multi-layered perceptron, meaning many of these perceptrons all connected to each other, what we can start to build and create afterwards. So that's my rambling introduction that apparently you just watched. Because we did. I mean, maybe no one will ever watch this, but probably somebody will. And I'll see you follow along. I look forward to your feedback. I hope this goes okay. What a humble brag. This guy has 250,000 subscribers. Okay, it's fine. And I'll see you in these future videos as I keep going. Thanks for watching.
Oh my god, this music. Let's jump to the next one. Because this video is the meat of what we're gonna do. Oh, it's not 250, it's like 500,000.
Hello, welcome to a coding challenge. In this coding challenge, I am going to attempt to make a perceptron. This is part of a whole bunch of videos that I'm doing about neural network-based learning. And but in this video, I'm not kind of getting into too much. Like,
yeah, I know you can't hear me over the video because the microphone is like. I will try to pause. He is going to code a perceptron, which is kind of like the simplest possible thing in a neural network. And what I'm going to do here, because he codes this in processing, which is super annoying. Processing, but the thing is, like, processing is kind of like his project, I think. He's very much involved in. I'm not sure if he was the inventor of it or like it seems to me like Shiftman is like the processing guy or one of the processing guys. So I think he moves to JavaScript later, but I think that the fact that he does this in processing kind of gives us this nice avenue into looking at the video and then trying to translate each bit to JavaScript, because that will force us into, that. And that, or at least that's what I'm going to try to do during this stream, during these sessions.
Much about the whole broader landscape of everything history-wise and future-wise about what's happening with neural network-based learning. In this example, I just want to build, with code, the simplest model of an artificial neural network possible, known as a perceptron. Perceptron, the concept of perceptron was invented by Frank Rosenblatt in 1957 at the Cornell Aeronautical Laboratory. There's a link here to the original paper, which I will include in this video's description if you want to take a look at that. And of course, you can always find more on the Perceptron Wikipedia page. What is a perceptron? Why am I even here talking about this? So ultimately, I want to look at artificial intelligence, neural network-based machine learning systems that are inspired by and modeled loosely off of the idea of the actual brain. The actual brain being this thing with like neurons and axons that connect to other neurons and dendrites that receive inputs. I actually don't know what I'm talking about. I'm just reading what's ever on this document. But a perceptron, and ultimately, where I'm going to start building examples and show you examples of lots of these components that are all interconnected, and inputs are coming in and outputs are flowing out. But I want to start with this idea of the perceptron being a model of a single neuron, the simplest possible artificial neural network that we could build. And this will serve as the building block for future examples that I will make in future videos. Okay, so let's come over to the whiteboard for a second. So if the idea of a perceptron is that there is a single neuron, call this a neuron, that neuron could have inputs. Let's say there are two inputs. I'm going to call them x0, x index 1, so inputs 0 and 1. They come into the neuron, some type of mathematical process happens in the neuron, and then there is an output, which I'll call y, or output. So these are inputs. And again, this diagram, it might look familiar to you if you've watched some of my other videos, because I often talk about this idea of there is some amount of inputs, a long list of inputs, that go into some machine learning recipe that processes all those inputs and performs a task. Maybe it tries to classify or perform a regression, but makes some sort of output, some sort of prediction. So this is exactly what this perceptron is designed to do.
I just want to make a digression here and say this annoys me to no end with mathematicians. Like these, oh, it's standing in the way, hang on.
Okay.
Like these x1 and x2 and y, and just name the things. Why? What is the benefit of using these super abstract things? It makes it's so much harder to reason about these things. Just say dog or whatever, house, or give examples instead of these generic things. We can talk about the abstractions later once we have examples. Don't go general concept first. It's super annoying. You don't. When you teach a kid the concept of a mammal, the kid has to have seen a cat or a dog first. It's so dumb. Humans don't learn this way.
Here's the thing. In order for us to understand and look at all of the pieces of what's happening in here, we need some scenario. So let's come up with a scenario that we can use. So let's say I have a two-dimensional space. You can think of this will be my canvas, my window. And what I'm going to do is I'm going to arbitrarily divide the space with some line. Some points will be on one side of the line, and other points will be on another side of the line. So essentially, what I want to do is use this perceptron for a classification problem. I want to say that these belong to, class A, and these belong to class B. So, and I'm going to use a supervised learning strategy.
Yeah, again, I like Schiffman. He is very good at a lot of stuff that he does, but I would like to have, like, at least, it doesn't necessarily have to be a real data set, but it would be good if he had, he could talk, like, at least invent like something that seemed real. Like if he said that, oh, these are houses, or these are, I don't know, these are breeds of dogs, or something that works for classification problems, because I find it really hard to, like, when I'm learning something new, to deal with the, like, general concepts everywhere. Like, it would be really good if there was some kind of fake reality somewhere. There's X here, and like my brain goes into overdrive just dealing with all these kind of abstractions. He could, like, it's necessary to deal with abstraction as a programmer and learning programming, but like in this case, he could have offloaded that for me, and I hope that we could somehow do that in this course. I'm not sure if, like, I might if I get better at this, I might make a course that explains it afterwards, or I'm not sure how to do this. It's all an experiment. I'm just nagging. Let's continue.
So for background on some of this, you could go and watch session 3 of my Intelligence and Learning series, where I do some other videos about classification and regression, and using a linear regression model. There's a lot of crossover here, but anyway, you can stay here if you want. I'm going to kind of talk through everything. But the idea is I want to classify these. So I want these inputs to be, so x0, for any point right here, like this, x comma y. It's a little bit confusing the way I'm using, I don't love this, because I should really think of the x is input 0, the y is input 1, right? The x is input 0, the y is input 1. The output is class A or class B, the y. So I'm using x and y in two different places in slightly different ways, which is a bit confusing, but hopefully will make sense.
That is so confusing. Okay, so hang on. So, all right, so this is a coordinate system, right? This is x and this is y, or is it y or x? I don't know. Either way. So x here and y here. So x goes here. So x is going to be x0, and y is going to be y here, and that's going to be x2. It's like, mathematicians, learn to name things. God. Math people. Math people.
As we continue to go along here. Okay, so, but I actually want to say, instead of...
Hawkeye says, it's not just about variable names, it's about situations and outcomes and all of it. When everything is expressed in abstract terms, it makes it so hard to just get a feel for why they are doing whatever they're doing. Oh! Hawkeye, that is so eloquently put. That is so nicely put. Like, notice here that we're just... He hasn't really talked about why we are learning this. What is a neural network for? He spoke a little bit about examples, but he didn't really get us super excited about the kind of problems that we're trying to solve. Like, I think that a good machine learning course, if I'm like just analyzing the things that I think are mistakes. This is turning into like a meta-analysis, meta-critique of Schiffman's series here by accident. But I think that it would be so nice if I could get some examples around, like, why. Like cool examples of neural networks. Like, talk about perhaps like the I guess that the thing that learned to the AlphaGo thing, that was probably a neural network, I suppose, maybe. Or like, I don't know, Discover Weekly is maybe a neural network, I have no idea. But just give real life examples of where neural networks were used and like get us excited.
instead of A and B, what I actually want to say is +1 and -1. So the idea is that my perceptron is going to output a +1 if the point belongs to group A, and it's going to output a -1 if the point belongs to group B. So and we're going to use the technique known as supervised learning. And what supervised learning involves is I'm going to ask the perceptron to say, here is some input, give me a guess, but I know the correct answer. I'm going to give the perceptron a point that I know should be in A. And it's going to guess either A and B. If it guesses A, I'm going to say, great job, perceptron, you keep on going. If it guesses B, I'm going to say, perceptron, you made a mistake. Let's tweak something about your algorithm to try to get you to the correct answer. And this tweaking is a process known as gradient descent, and it's something that I've also covered in a couple different videos that I will also link to down here. We're going to go through it as I get through here, okay? So that's the supervised learning process. Okay, so what is the actual algorithm? What happens here inside the neuron? So here's the missing piece. There's a few different missing pieces that I'll get to over time. I was stepping on something else. These you can think of as connections. The inputs flow into this neuron. Sorry. But are weighted as they flow in. So each one of these connections has a weight. I'm going to say W0, W1. So these inputs are weighted. And what the perceptron does, its algorithm, is to create a sum of all of the inputs multiplied by the weights. That sum is X input times, input 0 times weight 0 plus input 1 times weight 1. Now in this case, the perceptron only has 2 inputs, so this is a very easy formula to write. As you're going to see as I get into future videos, you might realize like, oh, there's 100 inputs, or 1,000 inputs, or 100,000 inputs. But this same formula is always going to apply. A weighted sum of all the inputs. Input 0 times weight 0, input 1 times weight 1, add them all up together. So that's step 1, is the sum. Step 2, so you could say like, okay, well, you take that and that's the output. But this isn't the output. Step 2 is something called an activation function. Activation function. And this is a key concept in neural network-based machine learning. As I get into future videos, we're going to see there's a variety of different kinds of activation functions. And why might you use this one or this one? And what do they do? And why? But typically what an activation function does is it allows you to conform the output to some desired range, and do things, and another way to think about it is if you think about that idea of the brain, like you can think of does the neuron fire and continue to send its data along, or does it not? So what happens as the data comes out of that neuron? We're going to use
Oblivioner asks, why dark walls? Well, because I haven't turned the lights on. They're actually not all that dark. They just look dark in the stream because they're not lit, and because this camera that I have to use for the live streams are a piece of shite. Excuse me while I turn the lights on. There, back wall is now a little bit more lit, at least. All right, let's continue.
In this particular example, we're going to use a very, very simple activation function. You can think, okay, well, I only want 2 outputs. I want a +1 or a -1. How can I take any number? I can take any number and convert that number into +1 or -1. How would I do that? How about a function called sine? Take the sine of any number n. If that number n is positive, then I get a +1. If that number n is negative, then I get a -1. Okay, so that's the activation function. This is the whole process. It's often referred to as feed forward. The inputs come in, they get multiplied by the weights, they get added together, and then that weighted sum gets passed through an activation function, and then that activation function gives us a +1 or a -1, should the neuron fire or not fire, and that gets sent out, and that's the output. Okay, I'm back from I was just checking a live chat that's going on. If you're watching this as an archive, that live chat doesn't exist, but there are 2 important questions before I move on. Number 1 is, what do you do with 0? I don't know. we could just arbitrarily right now, let's just say this is greater than or equal. So 0 we'll consider plus 1. I mean, in the case, this is just like a toy example just to demonstrate the idea. It's a building block. You know, I don't know how meaningful it is to be able to like classify points in 2D space based on a line. But
I love how Hawkeye thought exactly the same thing as his chat, and then his chat mentions that, and then I am now mentioning it in my chat. Meta!
But so at this point, I'm going to make an arbitrary determination for that. If it's on the line, you know, is it above or below? I'll pick one. The other question that was asked is, well, how do you pick these weights? So this is the essential question, and this is where I have to get to. So the idea is that through the supervised learning process, we want to search for. We're basically doing a search to find the optimal weights, the optimal weight values that will get the best results, those results with the least amount of errors. And so to start, we have to pick something to start. And in this case, we could pick random values. We could just start with the weights at 0. Well, that could be problematic. So there's different ways. This is a big topic in the field of machine learning. When you start a neural network-based system, how do you initialize the weights? Randomly? What kind of distribution of random numbers? Do you do some other kind of like learning process that gets to like a good starting point for the weights? That's a big topic of discussion and research. But for us, I'm going to pick random weights and then start to tweak them. Okay, so there's a lot more pieces of this still, but I think I'm going to go and start writing some code, and then we'll come back to pieces that we're missing. I'm going to do this in processing, which is a Java-based programming language and environment. You can find out more about it at processing.org. I will also release a JavaScript version of this that you can run in the browser. So
we will not be doing this in processing. We will be translating this to JavaScript. So, you know, I'm just gonna observablehq.com and do this in observable. Observe. Is that right? Observable is a fantastic software with the worst name ever. Hang on, let me create a new notebook. So it's kind of like this interactive playbook kind of thing. If you're familiar with IPython playbook, this is basically like hosted Python playbooks. Neural network from scratch, something like that. And you can use this to do like arbitrary JavaScript, like you can just do 5. No, sorry, like hello equals 5, and then you can do like hello, oh my god, this is a horrible example, but hello, and then that turns into 5. But the nice thing that makes this very unique and super useful and awesome to play around with is like I can change hello 10. Monica Supreme, can we join the scratch pad? Oh my god, I think you can actually. Hang on, if I publish this, shit, I turned a horrible URL untitled. I'm gonna paste this link in the chat. There we go. I think that you will now have this live updating. Let me actually just see if it live updates. So if I do like 16 here, does it live update here? Oh, it doesn't live update, but if I publish this here, it might do it. No, it does not. I have to refresh it, I suppose. No? Why doesn't it? I would have thought that this would live update actually. Oh, it does eventually. All right, well, let's see. This is the URL for it at least. Let's see if it. I will publish it from time to time so that you get it. And also you can fork. For the nice thing is that you can fork these things off. So if you if I go to this, hang on. There is there's this fork button up here that you can use to fork it off, and then you can, that will get its own unique URL. so that you can share it in the chat or whatever. This might actually turn out really nice. Anyway, let's go back to this and start watching him code.
For links to both source codes after it's over. Okay, so what I want to do, I want to create a perceptron class. So we can see here, by the way, I have this slide here. This is the same algorithm I just talked through. Let's just make sure we have it right. The algorithm is, for every input, multiply input by the corresponding weight, sum all the weighted inputs, and then compute the output based on that sum, pass through an activation function, the sign of the sum. So we can see, we can think of like, this could be the point at 12, 4, and these could be the weights of the perceptron. So what I'm going to do for this particular perceptron is I am going to create an array to store all of those weights. And I'm going to say it's an array with 2 elements in it. And in the perceptron constructor, I'm going to loop through all of the weights and give them a random value between -1 and 1. So, but whoops, you don't say void with a constructor. I don't remember how to program in Java baseline.
Okay, so what is he doing here? He's creating a class. Oh god. Stop using classes for everything. Do we really need that? I'm gonna try to do this with just functions and plain objects to as much as possible. Okay. So what is he doing? He is, let me start mouse possé so that I can point to things on the screen. He is doing a loop here, and he is, what does this random thing do? Does anybody know? This is processing, but perhaps it's like Python. Does it create like, what is this? What is this that he's putting in there?
Languages. Okay, so this is the constructor. And what I want to do in the constructor is initialize.
Okay, the Tyrion has linked to something. Math.random. No, it's not that. This is not JavaScript. Create a random number between -1 and 1. Okay. Okay, we can do that. We can do that. So the objective here is to create an array of floats, array of numbers, and every number should have like be between -1 and 1. So let's see here. Weights should be let's pull in Ramda. This, by the way, is one of the cool things about observable, is that you can just pull in arbitrary npm modules. So let's say weight or .range. I don't quite remember how this range works. How many was it? He wanted weights.length. Weights, but weights doesn't have a length yet.
The weights randomly. Okay, now.
I don't know. Let's pick an arbitrary one. We want 10. What does it look like? Okay, cool. We get a range from this, and then we just map that, and we have. We don't really care about the value. We just have a math.random. Random Ramda. Since exist. npm thanks. Oops. Are we getting it? Invalid module. Oh. Hang on. Let me actually pull up another notebook because I have a trick for this. I have a trick for this. It's because it's using some browserify thing to do this pulling in, and some modules work and some modules do not. No, hang on, it's using unpackage. It's using unpackage. So if unpackage works for an npm module, it just works automatically. But sometimes it doesn't, because the module is written in not the correct way. So there's thankfully this this browserify CDN called wizardin. But that thing is the maintainers, like, they don't think that hosting is important. So I've actually set this up for myself. Hang on, where is that? It's somewhere. Yeah, right, there we go. This is what it looks like. I'm publishing this so that you can get it, and I'm going to browserify random number. This should work hypothetically. So what I'm doing here is that I have this wizardin thing. It's browserify as a kind of service, and they provide you with a little, was it a Docker container, or like, I don't remember if I put it up on Heroku. It's on Heroku, so I just put it up. I think it's probably even put it on GitHub. I think I just forked it. Either way, it's this thing, and that is what I put up on Heroku here. And now I can pull in any module, such as random number. And how does this work? You do it with options here. Copy paste. Let's have a look at that. I'm just gonna try it out on here first. How does this work? Just paste this in here. -15. Okay, cool. Min -1, max 1. That was what his code looked like, right? And yeah, integer true. No, it's not. Can I just remove that? Brilliant. That's the way we want it. And I suppose we just do this. Cool. How does that look? Brilliant. And we get an array. Let me delete this and delete this. Fancy. Let me this thing. We want. How do I? Okay, I can click this to get it up. There's also a keyboard shortcut. I just hit Command, Alt, and then up arrow or down arrow and can navigate. Pretty cool. I thought you were foregoing modules in favor of writing your own code this project. Well, I'm foregoing like machine learning modules. Like, we're not gonna, like, there's no point in writing our own random functions. We don't learn anything about machine learning by doing that. And also, like for Ramda is something that, you know, like creating a range function. This like creating like an array, like doing that from scratch won't help us either. House of 3Ds points out that you can do it like this. Hang on, and high, low, if you want to do it from scratch. And I can just do rand 1, 4. Yeah, but that doesn't give its floats though. So I suppose that we do this. -1, 1. Oh, nice. That would work too. You know, for interactivity's sake, let's actually use the code that House of 3Ds wrote. Interactivity is fun. Hang on, I'm gonna just inline this, to be honest. No, hang on. It was pretty fun that we had it as a function, actually. Let's do this. Rand there, and then paste it in. Rand -1. There we go. Collaborative programming with the audience. Awesome. And we're at a good point, so I'm gonna publish the notebook so that you can see it at this earn. I'll paste it in the chat. Okay, let's go back to his code.
What are some things the perceptron should do? Well, one of the things it should do is it should be able to receive inputs and then compute a guess, an output. We'll call that a guess. Okay. So let's write a function. I'm going to call it guess, and it should return an integer, +1 or -1.
Oh, hang on. Monka Supreme asked why observable does not use function, let, and const keywords. You can. I could do like, I need to define a block first. So I can do like const x = 1, and then I could return x, and that would give me 1. So this value, this block evaluates to 1 now, or it evaluates to 2, or like, yeah. Or I could use let as well. I can also define functions. So function hello, return hello z, and then I can call hellos. Oops, sorry, from wherever. But like when we do when I declare something like my var equals, this kind of declares like an observable thingamabobby bob. So that is what gives me the ability to do stuff like this. I could do my other var, and this becomes a hello. This is a string that also uses my var, and this is nothing magical yet, but let me show you this. I use my third var is my other var plus, you know, xxxx. Now I can change this bugger down here to anything, and you'll see that this updates here. So having it this way allows observable to create these dependency chains. So this actually knows what observable values it's dependent on. So my third var knows that it's dependent on my other var, and my other var knows that it's dependent on my var, and that creates like this this dependency chain. So this creates these magic observable objects, and it could probably have used like some kind of other like more obvious syntax for it, but since this is such a common atom in observable, this makes a lot of sense. I thought it was kind of disgusting when I first saw it, but after a while I just leaned into it, and it's just very nicely. Monkasip Dream says, oh, it doesn't care about order. No, correct. It cares. It doesn't. Like, that is one of the things that is just mind-bending with, mind-blowing, I would say, with observable. Because order does not matter. And order does, like, what matters is, like, the dependency graph. Depends on which cells are dependent on each other. So, like, when things are, it doesn't matter if where something's located visually in the space. And this is like a huge advantage over IPython Notebook, where you have to like constantly execute things manually in the correct order in order for things in order to work. Here, the dependency graph is just calculated for you. It's so extremely nice and more human. Let me actually get rid of this, get rid of this, and jump back to Schiffman.
And it should receive inputs, which could also be in the form of an array. Now, I could, if I wanted to, because of the simplicity of the example, I could have done something like float w0 and float w1. I could just sort of have individual variables for the weights instead of an array. But the nice thing about doing it this way is this is more flexible, that this we could have, if we reuse this code later, we could adjust the number of inputs and that sort of thing with an array. Okay, so first thing I need to do is compute that weighted sum. So I'm going to create a variable called sum and initialize it at 0. Then I'm going to loop through all of the weights. And I'm going to say sum plus equal, what do I want to do? The sum of all the inputs multiplied by their corresponding weights. So inputs index I times weights index I. So this is now that weighted sum. I say that second step, start with the sum at 0, loop through, and multiply all the inputs by the weights. Then what I'm going to do is I am going to return, I need to get the, so then I'm going to say the output is sine of the sum. So it doesn't know what sine is. There probably is a like Java-based function I could call automatically, but let's just write our own. At the top of this code here, I'm going to write a function. I'm going to say int sine, and it gets, I guess I could say it gets any float. I'm going to say if n is greater than or equal to 0, return a positive 1, otherwise return a negative 1. So this is just that. This is the, so I could write here as a comment, this is the activation function. I could call it activate or something instead. The activation function is a function that receives some value. If it's greater than 0, positive 1. If it's less than 0, negative 1. So no matter what number goes in to the, whatever inputs come in, whatever that weighted sum is, no matter what, the only thing this perceptron can ever output is a 1 or a negative 1. So, and then I could say return output. So now I have basically, if I kind of give myself, nope, I really want, I guess this isn't, I want to see the whole thing. This is, if I have all the code for the, almost all the code for the perceptron. A perceptron has a bunch of weights, it initializes the weights randomly, and it can perform a guess by receiving all the inputs, doing a weighted sum, passing it through the activation function. Okay, so now, if I were to just create something arbitrary, just to sort of test if this is working, I'm going to say float inputs equals, I'm going to just create some random values like -1, 0.5, and I'm going to say print line, oh, first I'm going to say, I'm going to have a perceptron. I'll just call it P for perceptron. P equals a new perceptron. And then I can say P guess inputs. and I can say output. I can say guess, and I can say what's wrong here. What does it not like? Oh, this should be sorry. That should syntax-wise. That should these are the inputs. That's an array, and I should say sorry. Print line yes. So if I run this, how come I can't?
I don't think this will work yet.
If I run this, we should see, it outputted a 1. Let's run it again. I got a 1. Run it again. Eventually, I should be able to run it a bunch of times. And I got a -1. -1. Okay, so this, I believe, is working. The system works.
I don't get why this is working.
I can see. So these.
Wow, sorry for clicking around. Sorry.
X. I'm gonna flout, and I can make a guess.
This is
okay. So we
super weird that this is working for me.
-1. Okay, so this I believe is working. The system works. I have a perceptron object. I can
because weights dot like how does he like weights like doesn't have a size yet. Like why does this for loop even run? Why is there a weight there? That seems weird to me. Hey David. So like Cheeb watching a live stream, love it. If you don't know it, like Cheeb is the like that's David. That's his nick on the internets. Dear Tyrion, that's my only issue with Shiftman. He always uses these for loops in JavaScript when we have so nice functions for that. Yes, that is true. Like it's not like it's very obvious that he doesn't do a lot of JavaScript programming because it doesn't program a JavaScript like a JavaScript programmer would. And we have this, but that's why we are doing this series, to make it like I want to make a machine learning series that is approachable to approachable JavaScript programmer. Yeah, he did 327 Wolf. Didn't he initialize with an array of floats? Yeah, but the array is 0. It's like never mind. I think I understand the concept anyway. Let's do the guess function. Guess. Hang on. Function guess. The guess takes some inputs. Oh my god, the seagulls are going crazy right now. Inputs, and it takes some weights. And what he does is that he just sums, creates a sum with all the inputs and all the weights. So I suppose we just, how do we do this? Inputs, reduce. Can we just, isn't this a suitable case for zip? I've never used it. Ramda zip. Oh, here's the problem with Ramda is that you constantly go into these huge procrastination drives where you just try to find the perfect Ramda function for things. No, it's not zip, because zip creates... No, I think it's actually what we want. Let's look at... I need to formulate my full thought patterns here. Let's say that we have some inputs. Yeah, DR Karen says, yep, you can use it. So let's say we have some inputs. Inputs is what was his input? -1 and 0.5. and then our guess, I'm gonna call this test. Guess test as in kind of unit test. In test guess, and we're gonna call it inputs and weights. And that's gonna give us undefined because the guess function is just empty. So let's do lambda zip inputs weights. Let's actually return that to see what we have. It's an array of arrays. Cool. And then we're going to reduce that. And what's it called? I think that so if you're not familiar with reduce, it's the thing. Oh, I'm too lazy to explain reduce. I'll explain it once we've made it. Hang on. So we're gonna we're gonna destructure this actually. The first one is going to be the input and the weight, and then we're going to take input times the weight, and we're going to take the accumulated value plus that, and we're going to return, let's start with 0. I think this is gonna do it. Nope, didn't. Shite. Oh, why didn't this work? Thought that this would work. It was a lie. Dun, dun, dun. No, okay, I'm doing the destruction wrong. Ah, break time. I use a little. Yeah, the Tyrant points out that it's not an object. That's my problem. By the way, this software is awesome. It's really nice to just keep you from sitting around in the computer for too long. By the way, we've been going for 90 minutes, so we're gonna take a break soon. Yeah, it's not an object, so we should destructure it as an array. That sort of worked, I think. Did it though? It should. I'm surprised. Yeah, okay. So if I change the random weights here, that should. Yeah, cool. I think it works. Looks like I'm gonna pin this. This is a handy function. I can click pin here so that this is always visible. Bogdan asks, what are you using as a Pomodoro? Well, I don't understand the question. I work in 20 minutes blocks, if that's what you're asking. And I use a software called break time to freeze the screen. Monka Supreme says that what you're actually doing is a scalar product. Maybe there's a lambda function for scalar product. Maybe. No. I would say that this is where it comes into math territory. I wonder if maybe there is a scalar product tensor flow. Oops. Because I figured that this is something that math libraries... Jesus, what a car. This is something that math libraries do well. Anyway, I think we have implemented replicated the code that he has so far.
Run it again. Eventually, I should be able to run it a bunch of times. And I got a -1. -1. Okay, so this, I believe, is working. The system works. I have a perceptron object. I can feed in inputs, and I can make a guess. Okay, so we have the overall structure now for the perceptron, and it works. But we need some...
Okay, the Arterian points out that TensorFlow has a... hang on. TensorFlow has something called the dot, computes the dot product of two matrices and or vectors t and 2. Is this the same thing? Is this the same thing? So what you're saying is that we could use this instead of the reduce that we did? Can we do that? That would be pretty fun to pull in, actually. Like, because this is what I want to do. I kind of just want to play around and move really slowly through his examples and just think about them a lot and discuss them a lot. Like, just for my own, for myself and for you, so that we are like really not confused. Can I npm TensorFlow JS? Whoop, cool if we could just pull it in. Can you do this? I'm gonna see if I can pull this in. Hang on. Can I just do require TF? Can I do that? Oh my god. Did that just work? Let's see. Let me do a guess 2 here. And instead of the zip, we can use TF dot. Okay. Test guess. I'm gonna copy paste this and just do test guess 2. Cannot read property rank of undefined. It wants a rank? It's not TF dot. Tensor 1D? Tensor 2D? I get some really complicated event object. Hang on, size 2. Shape. Strides. Weird. For vectors, you probably want 1D. 1D? Requires values to be a flat typed array, yeah, but it is like, or like this is what it looks like. It's an array of arrays. Hawkeye says this has veered slightly away from adding up some numbers in an array. Welcome to the show, Hawkeye. That is you returned the tensor. Just use the tensor.print. Hang on. Let me try. .print. Oops. And then 2D. Undefined. Nah. and it will print it. Does it do that in the console or something? Okay. And like dot. Okay, so I suppose I do something like data. Can I do that? And then yeah, I guess you could probably use this, but we're frankly just getting confused. I'm gonna I think that Hawkeye is correct. We're just getting supremely distracted. This is, we're learning. Let's not try to learn two things at the same time. Maybe we could, like, I think that it might be an interesting exercise to like go through these later and then refactor them to TensorFlow, because I'm a big fan of using, like, starting out using simple things and then like showing how you can do them in libraries. Anyway, let's go back to Shipman. I think that I think it was the Tyrion that pointed out that next up is going to be the sign function.
We need to do more. So here's the thing. We need to create, if I had an actual data set, if I were to try and classify flowers, and these were sunflowers, and these were daisies, and this, the x-axis was like petal length, and this was sepal length or something, I could use a real data set here. I'm going to do something really phony baloney, and I think I'm going to like kind of almost be really ridiculous about it, which is that I'm going to actually just say that anything, wait, do I really want to do this? I'm going to do it this way. Let's see. Anything that is, let's just consider the line y equals x. Anything that's above y equals x is a +1. Anything that's below y equals x should be a -1. So I want to create a known data set that I can use to train the perceptron. So let's do that really quickly. What I'm going to do is, let me think about this. I'm going to, there's so many different ways I could do this. Whoops, sorry.
Did you do the sign function? Where are we at? We are at 19. Oh, that's the way I did it. So it's just sign, and if it's hang on, sign n, then if n is above or below 0, then we return 1, otherwise we return -1. Is that it? Yeah, yes. And how does, oh my god, shite.
Hello. Sorry, that's in my eye.
I'm jumping around here.
So many different ways I could do this. I'm gonna
jumping around.
So let's do that really quick. I could do this. Whoops, sorry, that's in my eye.
I want to see where is this? Where does he call sign?
Actually, just
where does he call sign?
Really phony baloney. I got a -1. The overall structure, I can feed in inputs, and I can.
Okay, so the gas, he just basically pipes the output from the sum into the output. Okay, fine. So I guess just sign like this. Only ever goes to, it's only ever -1. That's not my expected results. Oh no, because my random thing stays around because it hasn't changed, so the observable doesn't change. But if I do this, it's going to eventually like switch between 1 and -1 up here. So it works. We have replicated what Schiffman did. That's nice. Not too happy about this code, but hey.
Make a guess. Okay, so we have the overall structure now for the perceptron, and it works. But we need to do more. So here's the thing. We need to create, if I had an actual data set, if I were to try and classify flowers, and these were sunflowers, and these were daisies, and this, the x-axis was like petal length, and this was sepal length or something, I could use a real data set here. I'm gonna do something really phony baloney, and I think I'm gonna like kind of almost be really ridiculous about it.
For the YouTube video, I might actually try to do the petal thing, maybe, or like or invent some kind of real data set predefined, because this weird abstract thing just makes me have a hard time with it.
Which is that I'm gonna actually just say that anything. Do I really want to do this? I'm going to do it this way. Let's see. Anything that is, let's just consider the line y equals x. Anything that's above y equals x is a +1. Anything that's below y equals x should be a -1. So I want to create a known data set that I can use to train the perceptron. So let's do that really quickly. What I'm going to do is, let me think about this. I'm going to, there's so many different ways I could do this. Oops, sorry, I got something in my eye. So many different ways I could do this. I'm gonna make a tab called training, and I'm gonna make a class called point. And the point is actually just an input array that has 3 values in it. No. Well, let me think about this. Let me actually have the point have an x and a y, and also a, I don't want to call it class, a label. I'll just call it a label. Okay, so if I make a new point, when I make a new point, I'm going to say x equals a random width, y equals random height. Am I going to run into trouble without just using the pixel coordinates? Let's try just using the pixel coordinates. I don't know if that's going to be a problem. And then the label, I could say if x is greater than y, the label is 1, else the label is -1, right? That should give me everything above. I don't know what's above, what's below. So let's do that, and then let's write a little function called like show, where I'm going to say stroke 0, and I'm going to say if label equals 1, fill 255. Else fill 0, and then I'm going to draw a little ellipse at x comma y, a small ellipse. Okay. So what I'm going to do is I'm going to make an array of points. I'm going to make 100 of them. And
can I say that this drives me insane that he does this, like this class thing. There's a bunch of side effects, and it like everything is mingled together. Like, why do you use a class when you have like, oh, it's garble? Like, just we'll make it better.
And I'm going to initialize them, and I'm going to say points index I is a new point, and then let's make the size a little bit bigger, 500, 300. Then I'm going to do background 255, and for every point in points. This is an enhanced loop in Java for every point in points. I'm going to say p.show. So if I run this, we can see, yeah, I mean,
Designer and Geek, as amazing as coding train is, it always bugged me that Mr. Schiffman always takes shortcuts instead of practicing improving good programming practices. Like, I don't mind that he takes shortcuts. That's fine. It's just that it's just such a it's just an unnecessary mess, and also like a lot of classes where they don't have to be classes. It feels like it's just using a weird, like a lot of Java stuff. But perhaps like that is just me being colored by being a JavaScript programmer, where I'm able to do things like very straight and to the point. Like there's a lot of fluff around, like perhaps you can't do things outside of classes, or perhaps it can, like these functions are not classes. Just mingles things together, like it just makes it hard to follow.
Let's make this a square, so it looks a little less weird. And I can also draw, just to sort of like see correctly, I'll draw a line from 0, 0 to width on the height. So you can see I picked all these points. Half of them are on this side and half of them are on this side. All right, so now that I have all these points.
Oh, again, let's jump back to the, like, where was that show function?
I'm going to make an array of points, 300. Then I'm going to do a background, and I'm going to say points, index I is a new point. And then where I'm going to say stroke 0.
Okay, so show is like the render thing.
And I'm going to say
then he's going to, you know, how are we gonna do this? Perhaps like, can we do this with some SVG thing, or should we do this with C3? Perhaps SVG is kind of cool. How does this work? SVG. How do you draw a ball with SVG? Something like this. HTML. Thinking like something like this. This work. Okay, cool. By the way, this is one of the funky thing with observable is that you can just render HTML or Markdown in line. It's very nice. I'm not sure if they're doing JSX yet. D3. Danko is over. Yeah, observable can use Canvas. We could use Canvas here, but I think that SVG is actually a better better abstraction, because Canvas has this super annoying imperative API, while SVG works a lot better when you're doing declarative programming that we're doing here. Monka Supreme accurately concludes that, damn, that's cool. Yes, it is. So like, just let me show you what we're working with here. So let's see that we have, like, I can just inline a variable here, like xpos, and then I can do like, I think I can just, is it view of input slider. I think it's something like this. I'm just winging it here. How does this work? HTML like this. Hang on, I have to check this out. View of observable. How to create an course. Oh, they need a better name for this product. It's impossible to Google. It's gonna be cool, I promise. View of slider. This is how you do it. This no, this is not it. This is not it. Interactive. Interactivity. Observable magic interactivity. Where is the goddamn view of? There we are. View. Oh, it's just a slider like that. Thought it was. Okay, fine. Slide. Okay, what's the slider then? Paste that in. Alright, there we go. Finally. Now, A is going. I'm gonna just call xpos. There. See this? What? Doesn't it? Slider times 100. Now it. Jesus. This is not turning out as sleek as I hoped. There. Okay. This is what I wanted to show you. So you can create like these interactive configuration elements where with view of, and these controls will be reactive because it will notice that since this depends on xpos, I can now adjust. It's all pretty cool. Really like observable. I think I think that this will eventually just. It's kind of like Excel but good. And useful. I just wish that they renamed it to a name that was not dumb. They could have just. I think that it's not dumb enough. They could probably call it programming or JavaScript thing. No, that JavaScript thing would actually be possible to Google. Like this is. Like, oh, like this is such a good product, but like the person doing their branding is an idiot. Sorry, that person, but you need to do more thinking. All right. Hey Rust Y, glad to see you here. Anyway, what the hell was I doing? Yeah, I was trying to replicate this thing with because he's drawing this these balls depending on. I think that he's going. I think that he is going to fill them depending with a different color depending on what side of the space he is, and then he's going to draw them at their points. All right. And he's also going to create some random points. Yeah, right, because they are getting some random width and height, and he's okay. And these are some kind of global shite from processing, I suppose. That is like the space they are in. Okay, fine. We're gonna do that. But I'm feeling really hungry and I need to go to the bathroom, and so we're gonna take a 5-minute break before continuing. After that, we're gonna make the final push and try to do this implementation so that we are at the point where we have things drawing on the screen. By the way, before I do, I'm gonna publish this so that you can see it at this URL. I'm gonna paste it in the chat so that you can play around with it. I will see you in 5 minutes. Alright, I'm back with some coffee. It's gonna hang around a little bit while we wait for people to return. Oh. How do you take your coffee? Drink coffee at all? What's your relationship with coffee? My relationship with coffee is horrible. I tend to just constantly escalate my caffeine intake until I reach like horrible diarrhea / anxiety levels on a permanent basis, and then I just do a solid cutoff for a couple of weeks and return back to 0, and then I start ramping up again gradually until I reach it again, and then that's the cycle. Hawkeye, I take it black like my men. Huh. Ah. Bepusema, I forgot all the math I learned in high school. Can I still learn this, or do I need to do some relearning? I forgot all of it too. Like all of it is gone for me. So that's a question that I'm asking myself too. Like that's the question that this series will answer. I can tell you that I safely know very little math. I remember very little math. So if we run across some math, then we'll like relearn it together. Dear Tyrion, I've now written a function that draws circles. Observable is really fun. Why don't you share it, publish it, and we'll check it out. On stream, interactivity, distractions are amazing. I'm gonna close some stuff here. Hang on, I'll see. Whoops. Check out the Tyrion, follow along MPJ. Amazing. Okay, so this just draws a bunch of circles. Oh, yeah. Oh, this is so nice. Isn't it cool that you can just... It's kind of sort of like React, but you don't really have to care about React. It just reacts. Like, does this even change anything? I don't know. Oh, it's circles. How do I... Where is this call from? I'm too tired right now. It seems. Either way, it's really cool. The draw is happening in the first cell. Oh, of course. Jesus, I keep forgetting how interactive this is. Oh, that's so cool. I changed it and it just updates immediately. So lovely. So lovely. Monka Supreme also did something. Oh, Monka Supreme, you need to publish it, otherwise this won't work. It's they are private by default. Neochromer, dude, glad I catch you on stream. First, thank you very much. I'm from the third world country in Eastern EU, and now I'm in an EU country working as a front-end dev, and you are the reason why. That is amazing. That is thank you so much. I'm not the reason why though, you are the reason why, but I'm so glad to be a part of your journey that way. That's so cool. Congratulations, you're amazing. Okay, let's do things. Okay. All right. So the first thing that we're gonna do is to generate some random points on a canvas. I'm kind of annoyed that he just used like the width of the canvas. It's kind of weird. I think that we're gonna first define some variables here. We're gonna canvas width. Not sure about this. We might change this. Canvas. I'm kind of stuck in his thinking now. I want to. Perhaps we should use coordinate systems or something. Perhaps X max. It's better. And then Y max. And then we're gonna call this X max. Height can be Y max. I'm just gonna check out Monka's. Monka, when you published it, it's going to get a different URL. Oh, Neochroma works in Austria. Austria, like I follow this vegan bodybuilder guy called Vgains, and he goes to vacation in Austria all the time, and the country is just gorgeous. It's so beautiful. It's so beautiful you just get angry, like my own shit country that doesn't have Alps and crap. So impressive. Check this out. Nice. So cool that you guys are playing along. I think this is gonna be great. It's gonna be great. Let's see. So does this, okay, 800, we don't need it to be that large. I'm gonna call it 400 and then 200. All right, now our canvas is slightly a bit smaller. I want to create some points, and we want the points to be, how did he generate his points? All right, it was just a random position between the width and the height. So let's just call them inputs. I'm gonna throw away these. And they're going to be range. I think he did 200 of them. This range is not defined. R lambda range. And for each such one, we're gonna use the rand function that is chat written. which I love. And that was a numbered between x max zero when x max, I suppose. Expected end of input. Cool. Then we get a bunch of numbers. At the floor. Floor. Because we want them to be ints, and we want this to be we also want a y coordinate like this. So now we have points here, input points. New Chromer. I know Berlin is cheap, but it's just too far. Berlin is such a nice city. I really like Berlin. Change to YMax. Oh, thank you. Code review by chat is amazing. We want to draw these inputs. We want to draw these inputs. Inputs map point oopsie daisy, there we go. Thing like that. For each circle, point x, cy, point y. Can we do this? Unexpected end of input. Y, perhaps that one. Hey! All right, radius needs to be smaller. Stroke width 2. Wow, that was smooth. Cool. And if I just change this, it's... Woo! That was cool. Publishing, so that you can check it at this URL. Gonna paste it there. Okay, where were we? Gonna have a look. Let's have a look at this code again, so that we remember where we were. He does some stuff. Okay, so he kind of does the guess inside of the X. All right, yeah, because he's creating like this predefined data set here. That's the thing. That's the thing. So we need to do that as well. We need to do that as well. So his if the X is above the Y. Yeah. So if the X right. All right. Let me do this. Const X Yeah, he's marking them depending if x or y is greater. It's the code is clear. It's just that it's sort of unintuitive because it's so abstract. And then if x is greater than y, then his label is const label equals, and then he's marking them as 1 or -1, something like that. Cannot read properly. No, of course, and we actually need to return an object here, x, y, and label. Let it do. And then depending on the label, point dot label if that equals 1, then we should return green. Otherwise we should return red. So cool. Not quite what I expected. Why is it? I expected the line to go a bit more like through the entire thing. X is above y, he returns 1, and otherwise returns -1. Perhaps I'm thinking incorrectly here somehow. Perhaps it's not important, perhaps kind of want to understand why the line goes here and not the middle. What happens if I change this? Kind of tends to remain there. Oh wait, it's probably because it's not square. Oops. Yeah, that was it. That was it. Then it will be like geometrically in the middle. Dear Morsi, point, yeah, exactly. Monka and Tyrion and Morsi that pointed it out. Should have looked at chat. All right, so this is our sample data set. This is so-called, like, this is kind of what he imagines to be like the correct data set that we are gonna use as like the basis of our prediction. Which is weird, we have generated it, but well, what the hell. All right, let's continue.
I don't know what's above, what's below. So let's do that, and then let's write a little function called like show, where I'm going to say stroke 0, and I'm going to say if label equals 1, fill 255, else fill 0, and then I'm going to draw a little ellipse at x, comma y, a small ellipse. Okay.
So it's doing what we were doing.
I'm going to make an array of points. I'm going to make 100 of them, and I'm going to initialize them, and I'm going to say points, index I is a new point, and then let's make the size a little bit bigger, 500 times 300. Then I'm going to do background 255, and for every point in points, this is an enhanced loop in Java for every point in points, I'm going to say p.show. So if I run this, we can see, yeah, I mean, let's make this a square. So it's a little less
exactly
weird.
The same problem.
And I can also draw, just to sort of like see correctly, I'll draw a line from 0, 0 to width, comma height. So you can see, I picked all these points, half of them are on this side, and half of them are on this side. All right, so now that I have all these points, and I can see them correctly categorized. This is my known training data. So what I need to do, process-wise, is I need to take all of my known training data, one at a time. I need to pass it in, ask the perceptron to give me a guess. Is it in 1, or is it in -1? And then I need to do something based on whether it's correct or incorrect. What is it that I need to do? Okay, let's establish something. There's still some missing pieces here that I need to add, but I'm going to keep going. Let's talk about training. Let's talk about supervised learning. Here's what I need to do. I need to take all of that known data. I'm going to take each and every piece of known data. I'm going to take the x and y point and pass it in. It's going to do the weighted sum. It's going to pass through the activation function, and it's going to guess +1 or -1. Plus fun or negative fun? We're having some negative fun right now, I'm pretty sure. So this is going to give me a guess. But I also have the answer, right? So I have both the perceptron's guess and I have the answer. If I have both of those things, I can compute something known as the error. The error I can think of as, let's say the answer. I always get this wrong backwards, one way or the other, but it's the difference between the correct value and the incorrect. Sorry, between the correct value and the guess, right? Because if the guess is a +1 and the answer is a +1, what's that error? 1 minus 1, that error is 0. And I actually have a little bit of a diagram here, over here, where you can sort of see these are the only possible correct answers, -1 or +1. So there's only 4 possibilities. If it's supposed to be a -1, I could guess a -1 or a +1. If it's supposed to be a +1, I could guess a -1 or a +1. So these are all the possible errors. The error is either 0, or the error is -2, or +2, or 0. So this is a good starting point. I need to have this error. The idea here, let me come back to the whiteboard. Okay. So remember, what I'm trying to do is find the optimal weights. So ultimately what I want to do is I want to figure out I want to say, well, the weight should equal itself plus some change in weight. I want to adjust the weight. If there's a mistake, I want to make a tweak. I want to make the weight a little bit higher or a little bit lower, right? Because maybe my weighted sum got me below -1, but it should be a +1. If I make that weight higher, maybe that'll push the output up to positive. So the issue becomes, how do I calculate that delta weight? How should this weight change based on how should the weight change for weight 0, for weight 1, and if there were many, many, many more weights? So the way that this is calculated is with a process called gradient descent. And I have a couple videos where I go through this in pretty large detail. One way of thinking about this, which I'll kind of duplicate here in this video, is this really relates back to a lot of my...
I wonder how we will do this with gradient descent. It might be something that we should make a detour into, like an episode or something. Might do some math on the channel. Would be pretty interesting. I did I did a video on how to calculate the standard deviation using just JavaScript, and people seem to like that. I kind of like the idea of okay, the goal is to code a neural network, and then we just code until we get confused, and then we make a detour into maths until we sort of understand enough to proceed, and then we go back into the neural network. I think that is the way I want to approach this.
Steering examples. So I have all these steering examples where I have a vehicle that has a given velocity, and it's seeking a given target. So this vehicle has a velocity, and it also has a desired velocity, right? Because if it should be going towards that target, its desired velocity is to go towards that target. So you can think of the steering formula. If you go back to that Craig Reynolds steering formula, the steering formula equals the difference between the desired velocity, the way that I want to go, and the current velocity, which is kind of like my guess. And if I get this steering formula, if I get this steering function, if I get this steering vector and I add it to the velocity, it's going to cause me to turn and go towards that target. So essentially, that's what I want to do here. This steering vector is the error. The desired velocity is the answer. That's where I want to go. The velocity is my guess. That's where I'm going right now. I want to steer in the direction of the error. So delta weight, the delta weight is actually equal to the error multiplied by the input. So it's filtered through the input. What's that error filtered through the input? That's how I change the weight itself. So that's the process that I'm going to do over and over again.
I almost fell off my chair.
A slide here that I think we'll walk through that in. Oops, I'm in the wrong keyboard. Here. So this is the process. This is the supervised learning algorithm. Provide the perceptron with inputs for which there is a known answer, and ask the perceptron to guess. Okay, the perceptron guessed. What's the error? Is it right or wrong? Is the error 0? Is it 2? Is it -2? Adjust the weights according to the error, and go back and do it again and again and again. And this is the formula. The weight is changed according to the error multiplied by the input. And there's something called learning rate, which I'll get to in a second. So let's see now. I've kind of explained that in pieces. Let me see if I can now add that to the code. So I'm going to here, whoops. I'm going to now create a function in the perceptron. And I'm not going to call it guess. I'm going to call it train. So this is going to receive some inputs and a target. Right? The difference between a guess is something like, oh, I just want to receive these inputs and provide a guess. With training, I want to receive the inputs and the known answer so I can adjust the weights accordingly. Okay, so the first thing actually that I should do is just get the guess, which is actually guess with those inputs. So since I already have a function that does the guess, I can ask for the guess from that guess. Then what I want to do is get the error. The error equals the target minus the guess. That's the error. So now that I've done that, what I can do is
that the language allows you to do this is just ludicrously confusing. I don't think that this is a good thing to allow in your language. It seems weird to me. Just weird.
I can go through all of the weights and say each weight should change according.
Can you do this in JavaScript? Perhaps you can. It's criticized another language and they're like, oh, you can do that in JavaScript as well. You just don't. Like, this is just weird.
To that error multiplied by its corresponding input. So this is that particular algorithm. This is tune all the weights. Okay? So this is like basically supervised learning says, put the data in, get the result. If the result is right, just move along, nothing to see here. If the result is wrong, twist some dials in here to try to get it closer to the correct answer, and do it again, and again, and over and over again. You keep twisting dials eventually to find that optimal result. Now, there's something important here, though. If I go back to this steering example, you could think about, okay, so this is the vehicle, it's going in this direction, it should seek the target. It knows what the error is. The error is the difference between the way it should go and its current velocity. How much should it steer? If I steer all...
Okay, I'm gonna jump back to this.
So this is like basically...
What? Stop. Where is it? Give me the train function.
Okay, so this is like...
Okay. Yeah. Alright. Ash, my 2 favorite content creators on one screen. Thank you so much. That's so kind of you. The chair and the real fun will come with back propagation. That sounds like fun. Blackmark asks, is that Java? It's a language that he uses called processing, which is I believe it is Java based, but it's not Java. Anyway, let's try to implement this train function. Coding train function. Train. And its inputs and target. So target is an int, and then okay, so the guess. All right, let's do this. Guess result. Is guess input, and the error Yes, guess result minus something. Target minus guess result. Is that right? Cool. And then it goes through all the weights and it manipulates them in place. No! Ugh. And it takes the error and it multiplies it by the inputs. What? What is happening here? Pokemon Hole, MPJ, what kind of music do you listen to? Just good. Just turn to chat and be distracted whenever I find something hard. I listen to a lot of electro swing. I used to dance quite a bit of Lindy Hop, and I like electronic music, so that kind of came naturally that I got interested into that. I also listen to a lot of, you know, dark techno. I'm gonna give you, hang on, I'm gonna give you something that was just really nice that I listened to lately. Gonna paste it in the chat in a bit. Just gonna find it. It was a friend who sent something to me. All right. This one. This is a really I like kind of meditative dark thing. All right, let's try to figure out what the hell is happening here. He loops through the weights that are in the perceptron. These are the randomly generated weights that we started out with. And for every weight, he then adds the error multiplied by the input on that same thing. So kind of tweaks the weight a little bit. Dertiran says he's now adjusting the weights which are part of the objects. It makes sense that he adjusts it like this. Yeah. All right. Let's see. I kind of get it, but it's just not quite clicking naturally. Let's do it. Let's just try to re-implement it. So go through the weights. I'm gonna do this functionally instead. So instead of doing it object oriented, so we go through the weights, and this is a map. No, we're gonna zip them first. Or zip weights inputs. Is that lambda weight? Just gonna remember the syntax. RT Passion asks TensorFlow JS question mark. Yeah, but the thing with TensorFlow JS is that if we use that, this stream would basically just be import the solution and then we're done. We wouldn't really learn anything. It's more for people that already know these things. Then we're gonna map it, and we're gonna have a weight and an input. What does it look like? It's going to be input times the error times input. That should be the same as his code, I think. Cons adjusted weights. Dear Tyrion, again you need to use square brackets for these constructions. I never learn. I do learn, just very slowly. Okay, test train. Okay, we need to get the weights in there. Might give it a bit more space. Weights, and we want the inputs and the target. What's the target? Let me.
Basically, supervised learning says, put the data in, get the result. If the result is right, just move along, nothing to see here. If the result is wrong, twist some dials in here to try to get it closer to the correct answer, and do it again, and again, and over again. You keep twisting dials eventually to find that optimal result. Now, there's something important here, though. If I go back to this steering example, you could think about, okay, so this is the vehicle, it's going in this direction, it should seek the target. It knows what the error is. The error is the difference between the way it should go and its current velocity. How much should it steer? If I steer a lot, I could actually like overshoot and start going the wrong way in the other direction. But if I steer just a little bit, maybe I'm going closer, but I'm, and you realize we're going to be doing this with lots and lots of data. So one thing that's actually optimal here is not to steer the full amount all the way according to the error, but just some percentage of the way. And that percentage is referred to, it's a key concept here, and it's called, where's learning rate? So what I would actually do here is say that delta weight, this plus 1 here, is the error times the input, multiplied also by a learning rate. So that's a key concept here. So let's add that into our code. If I come back over here, the perceptron is going to have a variable called LR for learning rate. I'm just going to say 0.1. So now I'm going to say also multiplied by learning rate.
Okay, let's add that then. Learning rate and was 0.1. Was like this. Not super happy about these globals. Let's see.
Great. So there we go. Now this is going to adjust all of the weights. So we should be able to, if I go back to here, I should be able to now train the perceptron. So let's go here and say for all of the points. Oh, I did something terrible. Oh, I'm doing some awful stuff here.
Yes.
So I used P for perceptron, and then I'm using a local variable P for points. So let's call this PT for points. Let's actually just call this, I'm going to call perceptron, I'm going to call this like the brain. It's probably like a bad variable name, but at least it says something more than P. So for every point, what I want to do is I want to say brain.train the point, the inputs associated with that point, and the target, pass in the target associated with that point, right?
Okay. Hang on, what is happening? Let me do it. Look at that again. I'm kind of getting tired now. I think that these streams, like doing passing 2 hours for these streams is tough. It's tough.
Pass in the target associated with that point. right?
Okay, so where does it get the target from? Where's it? Okay, why does point have a target? Did you define that before?
The point, oh, it has an X and a Y and a label. So
yeah, it didn't have a target.
So the target is actually the label. And can I do this? I want to make something called inputs, which is an array, which just has...
Yeah, this becomes so confusing with this label and like... I would like it to be like flowers and petals and then like the actual value, or it becomes hard to juggle.
Point.x and point.y. Is Java going to let me write that? I think so. So this is what I want to do. I want to train the perceptron. I want to send in every point as inputs. So the x and the y make the 0 and the 1 input.
Okay. Okay. So we want the actual training data. So it loops through the actual data set. What was the actual data set? Was it these, the inputs? Sure. So for inputs, we want to, we just want to train the inputs until the weights are correct. So trained weights. This is the point where I just you're too tired to do programming, but the workday isn't over. That feeling. This is normally where the situation where I just start browsing hacker news, but I can't because it's a stream. And we could just stop the stream, but I kind of want to end it at a good point. So like let's just push through. Okay. So for every input, and it's probably gonna be a reduce, and it's gonna be like x. This is usually how I write the reduce, name the reduce variables in the beginning before I like decide what I want them to, what they actually are. And it starts with the initial weights. Like this is a bit dumb. It's better call it initial weights. So jumping back, it trains the inputs. So train takes the weights, and then it takes some inputs. Takes all the inputs, right? It needs all the inputs, and then it takes the target, which is the label. I think that's it. So I'm gonna label, give this the correct names. Input, and the ACK is actually the current weights. How does this? Cannot read property length of undefined. Why not? Inputs, that's an array. That should be reducible. Train. Weights, inputs, target. This is where the debuggability of observable becomes a little limited, unfortunately. Because it doesn't really tell me where the cannot read property length of undefined is shown. Is it even inside of this unexpected token? Okay, say 1 here. Okay, cool. So it's inside of train. Cannot read property length of undefined. That's probably inside the zip then, because we are not doing any. Kappadev says in your train function you need to add adjusted weight to the weight, I think. I don't know what you mean by that, sorry. So weights and inputs. What will, perhaps the train function will give us, what does train function give us? You know what, we're gonna do some console logging. Console.log. Do we even get some adjusted weights? Doesn't seem like it. Doesn't seem like it. I'm gonna move this up a little bit. Gonna call this debug dbg. Wait, what? Don't get that far either. Oh, it's inside of the guess function perhaps then. Yes, it is. It's a guess function that is broken. Okay, so guess gets inputs and weights. Guess there. And I'm going to remove the... Sorry for jumping around so much. I'm just going to remove this console.log. And see what this gives us. So let's clear this and do it again. Alright, so what do we get? Guess, okay, so weights is undefined, and that is probably why the zip function is failing. So the problem is that we're passing an undefined weights to guess from this from the train function, and yeah, that's the problem. Right. So there's some progress here. The problem is that we're getting just a lot of nan. Why is that? Okay, so let's check. Let's get rid of that console log. From and test this. Just gonna fix it with that. That isn't broken. Train. Let's have a look. Let's have a look at what guess gives us here. Console.log guess result. Okay, guess result is always -1. That's interesting. Okay, at least, but we get some. Which means that the error is always going to be -1. Okay. That's, don't know what to do about that. Console log. So does this mean that adjusted weights here is broken as well? This just gives us a bunch of let me do a console log inside of the reduce. God, I really missed the live comments that Quokka and Wallaby provides. It was so useful to have them in this thing. Weight, input, weight and input. See what this gives us. Okay, so weight. Weights, not a number. It's a log weights. Too many console logs. There we go. Okay, weights is just a bunch of nants. We don't want that. So from where are those coming? From where are the weights coming? Train is being called from this one. We're passing in some weights. But the initial weights should be coming here. Let me actually console log this. I'm suspecting that this is on the second run that things are breaking down. Also log weights. Clearing the console and then bam. Yeah, so they're nice on the first run, but then train gives a bunch of nans. Bunch of nans. Break time. Break time. You know, perhaps we should find a spot where we can call it a day. Perhaps we could, like, I think that this is probably a good spot to stop because we have a very, like, tangible error. I kind of want to stop here because I feel like I'm just, my brain is just fried. The Tyrann says, I think it's because you pass all the inputs. Possibly. Anyway, I'm gonna do this. I'm gonna go to Notion. And we're gonna make a new note. This might give you an insight into how I work. And stop stream aiming. And I'm gonna write in what way it's broken. The reduce inside of we are working on triggered from trained weights is broken on the second run, giving an array of nans. And then I'm going to also make a note of where we are. We are at in Schiffman's video, something like that. It gives us a way to like jump into this and begin like easily next time. And this is a way I really like working. And why not like to do? Sweet. To do, I don't like to do backlog. Nice. Oh, that was intense. We've been doing this for 3 hours. Thank you so much, everyone that stuck around and kept me going and helped out during the video. This is now published at this URL. If you wanna check it out. Adrian asks what the app is called, the note-taking app. It's called Notion. It's really nice. It's something that I'm trying out. Sector says thanks for the stream, MPGJ. Thank you for being here. I hope that you enjoyed it. Might actually continue this tomorrow to get some more meat into this and try to complete the neural network. Or maybe I will try to jump straight into coding a neural network episode try to record a YouTube episode. I'm not sure. I'm trying to figure out this format. Nothing is certain. Stumpkin says absolutely love Notion. Yeah, I think I do too. It's incredible. Like it's so much stuff you can do. Like these like mention a person, and you can date a reminder. You can link to other pages. You can create tables and Kanban boards. You can images. You can create like columns. Embed maps. It's just insane, and it's just full markdown support. And yeah, I think I like it a lot. I think I'm gonna use it a lot. Oh, all right. Dear Tyrann, do you have a rough time for that? No, sorry, I'm not gonna pre-announce yet. I know that sucks, but when it comes to streams, I'm just not ready to start committing yet. I will at some point, but not right now. Right now, I'm just trying to put all the pressure off myself, because I know how easy things become a chore, and you create negative feelings around it, and yet just sucks. It needs to be a labor of love. Cool. Any final questions before I close this stream? It's been good. I want to stream more. Twitch is amazing. It's so great hanging out with you and like having this immediate feedback and having people code immediately, and yeah, it's so nice. Hey, Solid Motion, I didn't understand your question. Oh, okay. Yeah, you wrote they rarely help me when I started learning JS. I think you meant really. So I thought you insulted me. Kind of like when people write weird stuff in stream, I kind of ignore them. Pokemon Hole, enjoy the stream. Hope to see you more. Have a good one. Yeah. All right, I'm gonna close the stream. Thank you so much, everyone, for joining. I had a blast. I will try to do more of this. It's so lovely. Closing down.